Welcome to linear algebra lecture number 39. Today is one of the most important lectures of the series. And why is that? Okay, why is today the most important lecture in the entire series? Because today you will be learning matrix multiplication. In other words, you will learn nothing new today, but except you will learn an algorithm. And in the future, you will understand why this algorithm works the way it does.
I have that matrix multiplication, the commutative property doesn't hold. Is that true?
That's right. And we will get a chance to investigate why. Not today, but a couple of...
that means A times B is not equal to B times A.
Wow. Yeah, very ahead. Yeah. So,
but metric addition, the commutative property hold.
So
that means A plus B equal to B plus A.
So you can say yes, it does form. Yeah. Okay, so today's do now, we're gonna, it's basically like a diagnostic. So we're gonna see how much you can do. Excuse me. Okay, so I don't know, 1, 2, 3, 4, 1 minus 2, 1, 1. Can I also...
Why you put plus? I thought you were going to teach us multiplication.
Oh, no, that's a few hundred, that's in the future. But let's take a look.
For multiplication today.
Okay, but let's be patient. Okay. Okay, so... is this enough? Yeah, that's enough. So go ahead, try to write your answers, and yeah, come up to the board and write your answers to what the sum and difference of these matrices should be. Okay. So oh no, there's an orange marker behind you. Right here.
No. We want to do the board.
Yeah, do it here.
So 1 minus 4, 1 minus 4. One plus 1, 2.
I think I did it wrong.
4, 5. Yeah, no, that's fine.
Oh, Alex, you want to share this?
Yeah. Alex is 1 minus 1 is 0. 1 minus 1 is 0. 2 minus 2 is 4. 3 minus 1 is 2. What is it? 4. 4 minus 1 is 3.
Wait a second. We've been stopped and we quite possibly been
Good.
Wait, still make it 2 by 2. We have
Who
been
made it easy?
So let's see, 1 and 1, 2. Okay, so hopefully that was a pretty easy do now.
Yeah.
And yes, now we're gonna proceed to
yes.
It was not easy, but we are smart.
yeah. So this seems to have been in your zone. So I will need to significantly.
It was not in the zone. It was easier than in the zone.
Now I'm gonna go to a topic that's so far outside of your zone.
We need scaffolding.
Not even scaffolding. It will look like foreign language, which I hear you've been learning.
Excuse me, can you push me with
Oh, the first
Laboratory?
class?
Excuse me, can you push me with Laboratory?
Oh, Lavagowski, he's saying he will
Okay.
take you 4 hours for your ZPE.
I want to begin with a very easy example.
You said very hard and now you think very easy. Like polar
Okay.
opposite.
So today is going to be a very nice lesson because we're going to go easy to... What does this look like?
Identity matrix.
Yes, Alex has recognized it, like our other student, but it is an identity matrix. And that is the key, okay? Now, if I multiply an identity matrix by any other matrix,
So that
what?
was a matrix.
Yes. In fact, we used to call it the magic matrix, right? So anything we multiply this by, what are we going to end up with? The same thing, right? So for example, we actually denote it as I for identity. So, and
It's
that's-
like 1 plus 0.
yes. In fact, that's called the identity property for multiplication. This is the identity property for matrices, okay? So one of our students has already resigned, but we will continue. Now, what is I times A? Well, that's simply
A.
It's A, yeah. It's IA, which is just A. And what is A?
Here is 2 minus 2.
2 minus 2.
3, 4.
Very nice. So already we know how matrix multiplication should probably work, right? So we already have a gist of what matrix multiplication will give us. Now, I will do something very important. Can we all look at the board? I am about to do something extremely important. What am I about to do? Let me show you. Okay, you see the 0?
Yeah.
I'm going to change the 0 into a different number. Give me a number.
2.
Wrong.
And the 3.
Nice.
To eliminate the 3, so we can get upper triangular form.
Oh, no. Oh my god. That's what you have in your mind? Give me a different number.
Negative 6.
Too big.
Negative 4.
Okay, I'll go with what you said before. 2. Now. Alex, would you like to guess what these two matrices, if I multiply them, what it will give me if I multiply these two?
Multiply, right?
Yeah, so we are in a new level, folks. This should be the most happiest day of your life.
Okay. So, should I do it?
Yes. So you go ahead, try your best while I discuss the utility of linear algebra to the folks watching. Alright folks, so if you don't know already, linear algebra is used to train artificial intelligence such as self-driving cars and Google's PageRank algorithm. Now, why is linear algebra the new calculus? Well, that's exactly what I'm here to answer.
Let's watch out.
Okay, so let's see what Alex said. So,
Maybe Alex can.
oh Alex, you want to explain?
Isaac can fix it.
Oh my god. Isaac, come up here, write your interpretation of what the answer should be. So I'll call this A. I'll call this matrix A for Alex, and I can't call it I because then it would be identity. I'll call it S for okay.
Okay.
So let's watch him find the multiplication, the product of these two matrices. Okay. So clearly we have two very different approaches here. Which one is right? Okay, let's see. What Alex did is he seems to have used the dot product somehow. At this point it seems like, yeah, it seems like he's ahead of the game. Okay.
Oh, no.
So as a matter of fact, Alex's matrix, I can say defiantly, is right. Okay, what about our other?
What? Defiantly?
Yeah.
What does that word mean?
Well, allow me to explain. So,
Is that mean good or bad?
sure.
he just lied to you to make
2,
more
6,
confident.
negative 2, 4. That doesn't look like.
I
what
was
we're
about to
looking-
drop the class.
Yeah,
that
let's
doesn't
drop it.
look like what we're looking for, but good job on the effort. So.
This is the first time
Okay.
I got right about it.
No, second time.
Now.
I mean, we're working as a team, right?
Let's try to understand what Alex did, okay? So today is kind of like an algorithm day, okay? So you might not look at things from a new perspective, but this is a very, okay. So,
Oh, I get it.
Yeah,
Let me see.
okay. So, this is what Alex did, okay? To understand what Alex did, the first thing we need to do is assign location, okay? So, what is the location of this entry? What location is this in? Do we know, folks? What location is this?
It's I'll tell you F1.
No. It's F11.
Mhm.
Row 1, column 1.
Yeah.
What about this one?
F21.
F21. Because row 2, column 1. What about this one?
F12.
Okay, nice. Because row 1, column 2. What about this one? Okay, we've just hit up. So this one is going to be F22. Now, folks, do we see an amazing pattern? Folks, okay? Let's look up here. So, look, so, for example, okay. So, let's say we didn't know what Alex put down, okay? So, let's say this was invisible for 1 second. How would we find what goes in F11? Do we have any ideas?
Well.
This is very magical. Ready?
Wait.
Look. 1, 1. Okay.
I have a good idea. 2 times 1, 0 would be 2 times 1 plus 2 times 0.
Okay, very good idea, but not quite. I need the markers. I need the marker, okay? So this is not quite the right idea. The right idea is, what does it say here? Folks, do we know what it says here? F11, right? So when we see the number 11, that gives us a signal. Take the first row of the first matrix. What is the first row of the first matrix? 1, 0. Okay? 1, 0. And take that dot product of that row with the column, with the first column of the second matrix. What is that? 2, 3. And folks, what is this dot product? Do you know? Can you tell me? What is this dot product?
I was right all along. You lied to me.
2 plus 0.
2 plus 0, right? 2 times 1 plus 0 times 3, which is simply 2.
Oh.
Which is exactly what Alex wrote, okay? Now, I want you to use the same strategy that I just gave you to find what F21 is, okay? Use that same strategy. Who wants to come up? Oh, I see Alex has raised his hand.
No, I'm kind of sleepy. I'm not gonna go.
Thank
No,
you.
why is it? Can you go?
Okay, I found a willing volunteer.
I never said willing.
Now, is Isaac attempts to complete the
Oh,
problem?
no.
Excuse me. Can I go? Can I go outside to put some water on my face?
Okay, hold on. Let's try to understand why linear algebra is the new language that you should learn. And of course, if you don't know why yet, go ahead and try to listen to what I'm saying. Now, what I'm about to say is that linear algebra may be the new language to learn. Okay, the language of matrices is really the language used by computers all over the world, including supercomputers that are trained by the likes of Google, Facebook, and Microsoft. Okay. Now,
Wakey.
what is your final answer?
7.
7. Okay. So let's try to see if that approach is right. Okay. So F21, right? So that means we take the second row of the first matrix. What is the second row of the first matrix? 2, 1, right?
Yeah.
Okay, so 2, 1. And we take that dot product with the first column of the second matrix. What is the first column? 2, 3. 2, 3.
So it's 4 plus 3.
4 plus 3, which is 7. Okay, this is going very well. Alex, would you like to show what F12 is with this new method?
Yeah, F11 was 2, 1.
I think somebody stole your marker. Probably was out.
F12.
Here it is.
2, 1 was 2. Okay. This is F11, right?
Right.
Okay, so 2. So hold on.
So let's
Hold on.
give Alex some hint.
No,
He's
he made it.
sabotaging you. He could be sabotaging you. Alex, look at it a little closer. He could be sabotaging you.
Of course, we can all take this time to learn about why linear algebra is so
Dude.
useful in today's world. And that is because computers are becoming ever increasingly omnipotent.
So what I have to do?
So you have to find what F12 is using this new method.
Okay, so 12. Where is 12?
So F12, right? So this is your goal. That's what you want to find. So F12 means take
This is
the first
This
row
is
of the
F11.
first matrix.
this is F11.
Mm-hmm.
This is F12.
Oh no. This is a completely different matrix.
Okay.
So take the first row of the first matrix. What is
The
that?
first row of the first matrix is 1 0.
Yeah. So write it down.
So I'm gonna write 1 0.
Mm-hmm. And now take the second column of the second matrix.
Second column of the second matrix. 2 4.
And negative.
Excuse
And take
me.
the dot point.
So
Oh,
it's gonna be negative 2 0.
Yeah. Oh no, you add them.
Alright then. So negative 2.
Negative 2. Yeah, perfect.
Was it existed?
And now we are gonna go to the exit flip, okay? So this exit flip is designed to, of course, don't worry if this was a confusing lesson. That was exactly the intention, okay? We're gonna clear this up through many examples and practice problems in the future. But for now, let's end with an easy exit
Yeah. What
flip.
is all the class? Yes.
Okay. So, our exit flip is this, okay? So, now this may be a difficult exit flip, but it should serve as a kind of review of what you just did. And of course, if you need help with it, then you can always ask me for some scaffolding. Okay? I'm just setting it up here. Okay, so let me call this matrix A, let me call this matrix B, and I'll call this matrix AB. Or as a matter of fact, to make life easier for you, I'll call it C. Now, so in the lesson, if you recall, we were doing a specific problem. Now what I'm going to ask you to try to do is to generalize what we just did. That's to generalize what we just did, okay? So let's see. Okay, folks. So go ahead, come up to the whiteboard and try to express the matrix C in terms of the entries that are given. Alright, as always. Okay, do you want to try to do that? Okay. Go ahead and try to do that. Oh, no, do it in the book, please. Give me the...
So this is easy.
Yeah. Now,
hey, 11 equal to dot product. Wait, what? 5 siblings? So dot product of
now let me kind of elaborate on my philosophy, and that is this. We begin by always assuming that the student is wrong. And why do we do this? In part, this is because we must make the student humble. As you may recall, one of the key tenets of Page's second
So
stage,
A11.
which is
11 plus
pre-operational, is that students are egotistical in their hypotheses.
this.
Okay, so in order to make them humble, we must present them with the facts. Look at his gun.
No. That's
And,
part of
doing
it.
so,
And then, wait. And then, that would be the same thing for the other one. A1, 2 would be the second column. So this would actually change to B12, B22. So this would actually be B12.
Of course, I encourage you to go ahead and try this out on your own at home. And this is a very nice exercise in matrix multiplication.
Plus 8, no.
As a matter of fact, matrix multiplication is not traditionally performed by computers, but back in the 1970s, this was a huge. Oh,
Well, no, I'm taking to my time.
okay, so let me show you the right way. Okay, so Alex, would you like to try? Huh?
Yeah, it's easy.
Okay. So you have to write it in C. So there was a very silly mistake here, and that's this thing. So when you take the dot product of this row and this column, right? You multiply A11 by B11, but instead you multiply A11 by A12. So the correct response would have been A11 times B11 plus A12 times B12. A12 times B12. You made the same mistake here. So for example, we take this row and multiply it by this column.
So
You make the same mistake for all of them.
B11 and A22 times B21. A22 times B21. Here we can find the same mistake, which is this row times this column. A11 times B12, okay, and A12 times B22. So A12 times B22. And the last one, we can just straight ahead go and write A21, times B12 plus A22 times B22. Now, if that seemed a bit confusing to you, don't worry, we're going to cover this in depth in the future lectures. So thank you for watching, and we'll see you next time.